Okay, I'll start this one off by confessing I lied to you in the last video. We're not going to do a quadratic. We are going to do the reciprocal function. Okay, you remember this one? It looks like this. We studied quotient reciprocal functions. It's one of these. Okay, but the idea is the same, that the slope is not constant here. The derivative, which is the slope of the tangent line, changes depending on where you are, right? So here we are looking for the slope of the tangent line at where x equals 2. So maybe this is where x equals 2. We want to know the slope of this line that is tangent to the point on the function that has an x value of 2. Okay, so first we'll predict that, well, that slope looks negative, so we hopefully will get a negative answer here. Okay, so the formula is the same for any function. To find the derivative, you take the limit as h approaches 0 of the rise, which is f of x plus h, minus f of x. Remember, that's the rise of the secant line, and this is the run of the secant line. And as you shrink the run of the secant line becomes the tangent line, and that's the slope that we're interested in, right? Okay, so just like before, we look at f of x plus h, and we look at f of x. Okay, and remember, x is 2. We only care about this at one point, at where x is 2. Okay, so, well, f of x, well, that's f of 2. And, well, 1 over 2. Don't need to simplify that. Okay, just plugging in 2 for x, 1 over 2. There we go. Now let's find f of x plus h. X is 2 plus h. Remember, we don't substitute anything for h because that's our limit variable. Okay, 2 plus h, that just means I substitute 2 plus h in here for x. I get 1 over 2 plus h, and we cannot really simplify that at this point. I know you want to split it up into 1 over 2 plus 1 over h, but remember, those two, that's an improper way to simplify that. We've talked a lot about that, why that's wrong. Okay, so we have to leave it like that. Now we substitute this in for f of x, and we substitute that in for f of x plus h. So let's do that. Our derivative becomes the limit as h approaches 0. F of x plus h is 1 over 2 plus h minus f of x, which is 1/2. And that is all over h, that one right there. Okay, this is a little bit more complicated than the last one, but it's nothing we can't simplify. Okay, so first we ask, can I just make h 0 and solve this limit just by directly substituting 0? Since h is approaching 0, let's just make h 0 and see what happens. The answer is no, because we still have a 0 denominator. So let's see if we can't simplify this fraction until we don't have a 0 denominator when we plug 0 in there for h. Okay, that's our goal. How can we simplify this? We could subtract our fractions on the top here. Okay, if that was your idea, you'd be right. But in order to do that, we first need common denominators, and these denominators are not common yet. You remember the way we get these common denominators would be to multiply both fractions by something such that their denominators will be equal, right? So I'm going to multiply this fraction by 2 plus h over 2 plus h. And I'll multiply this fraction over here by 2 over 2. Okay, I take the denominator of that one, multiply this fraction by that denominator over itself, and I take the denominator of that one and do the same over here. You guys have done this before. This is nothing that should blow your mind at this point. We've done this kind of thing when we're simplifying expressions. Okay, so what do we get? The limit as h approaches 0. Well, this is going to become 2 over, because 2 times 1, and then 2 times 2 plus h, that'll become 2 plus 4h, sorry, 4 plus 2h. If I distribute that 2 in there, right? Minus, over here, my numerator becomes 2 plus h over, and my denominator becomes, well, it's the same. And that's the whole reason I did that, was so that my denominators would become the same. And that's still all over an h, remember? Okay. Now that our fractions on top here have the same denominator, we can combine those. So we're going to get the limit as h approaches 0 of, well, on top we'll have 2 minus, now here's where you might get tripped up. 2 is subtracting this sum, 2 plus h, all over 4 plus 2h. That is all over h. We still got this fraction within a fraction thing going on here. Okay. Well, Luckily, we have 2 minus 2, and we can distribute that minus in there. So we have 2 minus h. 2 minus 2 is 0, so we really just get minus h there. Okay, so let's write that out. Limit as h approaches 0, this numerator just becomes minus h over 4 plus 2h all over h. Okay. Now let's try to deal with this fraction within a fraction business. I have a fraction divided by a variable. Now you might remember that the way we've been dealing with this is rather than dividing by h, why don't we just multiply by the reciprocal of h, right? Same thing. Dividing is really just multiplying by a reciprocal. Okay, so I'll take that up here. Let's see if I can fit all this on the screen. Looks like I can. Okay, so I'm really just taking the limit as h approaches 0 of this fraction, negative h over 4 plus 2h times the reciprocal of h. What's the reciprocal of h? 1 over h. Okay. Now what do we get? We can multiply these fractions together. We don't need common denominators now. So we get limit as h approaches 0 of negative h over, because negative h times 1. And you know, I could multiply these together and distribute the h, but I'm going to leave it factored out like this. Because you see now that we have an h divided by an h, right? Since this h is a factor of my entire denominator, and this h is a factor of my entire numerator, we can divide those out, right? So what do I get? Negative 1 over, sorry, I should write limit, shouldn't I? Limit as h approaches 0 of negative 1 over 4 plus 2h. Now, we can't simplify that any further inside the limit, and we still haven't gotten rid of this h in the denominator. However, the nice thing now is h is approaching 0, right? And what you'll learn in the next section is to solve a limit. If you don't get an undefined answer, you can go ahead and substitute 0 in there for h as long as it doesn't make anything undefined, right? Before we couldn't throw a 0 in because we'd be undefined, but now if we throw 0 in there, we get negative 1 over 4 plus 2 times 0, which is just 0, so we get negative 1 over 4. Okay, so why don't we just plug in 0 for h at the start? Because it would be undefined. Why can we plug in 0 for h now? Because it's not undefined, and we get an actual value, negative 1/4. So we just had to do some simplification work to get here. Negative 1/4 is the derivative. What's the derivative again? It's the slope of our function, the slope of the tangent line, and that line is tangent to our function at this point, x equals 2. Okay. So I hope you understood all of those steps. If not, see me in Zoom. I've been pretty lonely in those Zoom sessions, guys. Only about a handful of you have been showing up each time. So feel free to come and just say hi. I'd be happy to see you and see how you're doing and help you with some math. Okay, we got probably 2 more videos in this series, and then we're done. Bye.